Hi, I'm Kristin Oviedo, and this is Planetary Shapes and Gravity. One of the true definitions of a planet is that it is large enough to be rounded by its own gravity. And it's a little hard to see exactly why that is, and so here we've got a really simple diagram to kind of figure it out. So here we've got two massive planets. The first one is round, just like any sufficiently massive planet is. And so we've got to look at one little chunk of the planet and how it's being pulled upon by every other little chunk of the planet. And so the little chunk of the planet right here is going to pull on it in that direction, but then there's going to be another one that's going to pull on it in that direction, and here, and here, and you get the idea. I could draw an infinite number of chunks and they would all be pulling on it. But then if you look down here at this planet, it's got this weird little bump in it. And so this chunk is not going to have as much symmetry with how it's being pulled upon by all the other little chunks as this one is up here. So you'll still have your little chunks over here like that, a little chunk there and there, but then you've got all these other little chunks that are pulling on it and not a lot to balance it out side to side the way that you have up here. And so the tendency is going to be for this chunk to be pulled upon harder than all the other ones on the sides, whereas here it's pretty much equal to every other one. So basically what I'm trying to show is that this little outlier, this little weird bump here, is going to be pulled on hard enough to correct it and make it smooth along with everything else. And so that's going to happen with any number of bumps that you're going to have on any kind of weirdly shaped planet. This situation also answers kind of a corollary question, which is, why isn't a planet, like a pyramid shape or a cube shape, and really any other shape but a perfectly round sphere that has every point the same distance away from the middle? All of those shapes are going to end up having little sharp edges that stick out just in the same way that this does. And so once again, if a planet, started out as like a cube shape or whatever, all the little corners would be pulled in harder and it would always tend back towards that spherical shape. So in physics, we call that hydrostatic equilibrium, but that's way too much to get into right now, so we'll just stick with that term. I'm Kristin Oviedo, and that is Planetary Shapes and Gravity.